Okay, so today we're going to actually work on determining solutions of the systems of inequalities. Okay, so the last few classes we worked on forming the systems. Now we're going to look at actually figuring out which points are solutions to my systems. Okay, so when you have inequalities, you're giving a range of answers. So you're saying any number greater than or equal to this number, those are all of those points are solutions, right? So we're going to have a solution set. And what we want to do is figure out points that are actually in our set of solutions, okay? It'll make more sense in a second. So there are two ways this can be done. One way we can figure out whether a point is actually part of our solution set is by plugging the point into our system and simplifying to see if it actually works for all of the inequalities in our system. The second way would be to graph our systems, and we want to graph them with shading, and then we actually want to verify by looking at our shaded graphs whether the points are actually work for both or all inequalities, okay? So look at an example in a second. Some important things you need to remember, because you've seen this before, okay, is that if you have just a less than or just a greater than symbol, it doesn't have the or equal to part on the bottom, then you're going to give that line a dashed line, okay, because it can't actually equal the points on the line. It's either just going to be great, all the points greater than, less than, or all the points greater than that line, right? So to show that it can't actually equal the points on the line, you give it a dashed line, okay? And then if you have less than or equal to or greater than or equal to, that means it's everything less than and as well all the points equal to on that line, or everything greater than and everything equal to that line. So you give that a solid line because that shows you'll shade either above or below, and then it's all of the points less than as well as the line, or all the points greater than as well as the line, okay? So that's the difference between these two. And then if you have less than or a less than or equal to symbol, then you're going to shade below the sign, below the line, because with those signs, less than is everything lower than the line, right? And then for greater than or equal to, you're shading above the line because we want all the greater, higher up above points on our graph, right? So below the line, for less than or equal to, you're shading lower, right? For greater than or equal to, you're shading above, okay? Okay, so we're gonna look at graphing inequalities, okay, just briefly. When they're in this form where you have y by itself, super easy, just like graphing an equation, we're just gonna add the shading part, okay? So we're gonna plot our points. Let's look at this first one, okay? Our y-intercept is the number without the x, so our y-intercept is 5, meaning we have a point at 5 on my y-axis, and then our slope is 2, so we're going up 2 over 1, up 2 over 1, you get the gist. So this would make our line. It's got the or equal to underneath, which means I give it a solid line. Okay, and then it's everything that's less. Why is everything less than this line? Okay, so we're shading lower. Think less than. If you take a point on that line and you draw your arrow down, that's where you're shading for less than. Okay, let's do it we'll do this one in pink. Okay, so it's everything equal to that line, and then also everything lower below the line. Okay, and then we have y is greater than 3. Okay, so what we're going to do is we're going to find our y is at 3, and it's a not equal to line. It's just greater than, not equal to. So at 3, I'm going to give us a dashed line. Okay, and we want everything greater than. Why is anything greater than 3? It can't actually equal that line, So I'm just gonna shade everything above that line. Where'd blue go? Here we go. So I'm gonna shade everything above. And then the section where they overlap, that is my solution set. So it's everything on the solid line and everything above that dashed line and everything in between. Okay, so this is my blue. Okay, so everything that's in the pink, those are solutions to just the first inequality. Everything that's in the blue are solutions to the second inequality. And everything in purple, solutions to both. Okay, so same thing. We have y is greater than negative 3x plus 1. So I have a y-intercept at 1. My slope is negative 3, so I'm going down over 1, down, and over 1, or up 3 in the opposite direction over 1. So that's our line. It doesn't have the or equal to, so we give it dashes. My line was not very good. And then we're gonna shade it in pink. So it's everything greater than that line. So I choose a point and I draw up. That's where I'm shading, okay? Everything greater. And the next one, y is less than x minus 2. So we go to negative 2. And my slope is up 1, over 1, up 1, up 1, over 1, up 1, over 1. It also doesn't have the or equal to, so it's also getting a dashed line. Okay? And we want everything less than that line. So the overlap is all of that. Okay, so another way you could do this is using desmos.com and using the graphing calculator. So if we look at the first example I showed you, y is less than or equal to 2x plus 5. I'm going to turn that on. It automatically shades it for you, and it does the solid line for you. Or for our second one, y is greater than 3. It shades it, and it also puts the dashed line there for you. You can see the red is the solution to your first inequality, blue is the solution to your second, and then this kind of purpley part in the middle, that's the solution for both, where the two inequalities overlap, right? Where they overlap, those are solutions to both of the two inequalities, okay? Okay, so you can also see inequalities like this, where the x and the y are both on the left. If that's the case, you would have to solve it to get y by itself. Or if you're using desmos.com, you can type them in just like that. You see how it shaded above the line already for us, and it made it a dashed line. Okay, and then our second one is in purple. It also shaded it for us, and it did a solid line. And you can see that this part in the middle where they overlap, all of these points are solutions to both inequalities, right? So if we were to look at this point right here, 0, 2, this point would be a solution to both inequalities, the top one and the bottom one. We'll get more into that next class. But that's it. You just need to know how to graph them today.